Now we're going to jump ahead and look at examples where we actually write multi-threaded code where our different threads share data. And in this, we're going to look at the use of a keyword called synchronized and also see where we're going to still have problems with threads sharing data. Before we start, let's talk a little bit about what synchronized means. Synchronized is a keyword that, when applied to a method, requires a lock to run. And what that means is that when a method is synchronized, it's going to be locked so that only one thread can have access to it. Because what happens if two threads are trying to access, say, a variable at the same time? Well, that's called a race condition, and your program will lock up and crash because both threads can't have access to one variable at the same time. Another problem with race conditions is even if one thread gets to a variable before the other one, it may not be in the correct order. For example, if you have multi-threaded arithmetic operations going on, and an addition has to happen before a multiplication, if the multiplication happens first, the results of the computation are going to be different than what you were expecting. So to demonstrate all this, we're going to use a very classic producer and consumer example, where we're going to create two classes, a producer class and a consumer class. The producer class is going to produce integers, for lack of a better product to produce, in one thread, and the consumer class is going to consume those integers in another thread. And then we're going to demonstrate what happens when the proper coding procedures for dealing with multiple threads isn't written properly. So let's get started. We're going to call this program pnc.java. We're going to start off with a class called market, and that's just going to be where we're going to have two synchronized methods that our producer and consumer classes will utilize. Get is the first method, and put is the second method, and you can guess what these are for. The consumer class will use get to get an integer, and the producer class or a producer object will use put to produce an integer. Now notice we have the synchronized keyword in front of each of these methods. This guarantees that they will be locked when engaged so that multiple threads cannot be trying to access them at the same time. All right, next up we're going to create the producer class. We create a market to produce into. Then we create a new thread. First we get a market in which to produce. Then we get a new thread and start it. In the run method, we're simply going to produce integers by incrementing I. So I starts out at 0, and we simply continue to put new versions of I while the loop is running. Next, we create our consumer class. The consumer also takes a market object in its constructor. And we start the thread. The run method for the consumer object also has a while loop, and in the while loop all we do is get. Since we're not producing anything, there's nothing else to do but get integers that are produced by the producer. Finally, we have our PNC class. Here we create a new market, a new producer, a new consumer, and then a little message to the user that to stop this program, type Control-C. And we do that because it's going to run continuously if we don't. I'll show you how that works in just a second. So let's save the program, then compile it. Now I'm going to let it run, and we're already getting out of control, so let's stop it. And let's run it again. This time I have to do it fast. Now, let's see if we can get a good feel for what's going on here. Yes. Notice that what we should be getting is a put and a got. Put 0, got 0. Put 1, put 2. But notice what happens. Because we don't have any way to know when a thread's going to execute and run, we simply have what looks to be random and chaotic puts and gots. Not at all an orderly market, which is why I use that name for the class, which is what you want. Let's run it one more time, so you can get a feel. Now again, you see, look at that. Here we had many puts first before we ever got our first got. And our first got's way down at 16, so we can see that we're not able to follow all the transactions as they occur. So what we need are some additional commands, if you will, to organize the cooperation of the threads. And so in the exercise for this chapter, where we're going to stop, is demonstrate using some methods called wait, notify, and notify all, how we can organize this producer and consumer example to make it work correctly. And we're going to see how to do that coming up in this exercise.